I would like to talk about ice cream. The reason for this is that David and I are here sort of incognito in that we represent a company that was possibly going to be sponsoring the conference and recruiting and being revealing themselves as a Python development house, but they want to get the first version of the product released before they can do that. So we're going to explain about ice creams instead. Because the same principle applies. The major ice cream company that we work for, and their West London dishes are second to none. We have here a very nice ice cream parlour with some prices of products that we can see there. And thinking as Python developers, how would we price these in a way that could be useful to a front end? So we'd have a front end website talking to a pricing engine saying what products are available in what combinations and how much will they cost. And it's important to design a system that wherever you call it from somebody selling in a shop or online or by the phone, they all need to be given the same price. So if we look at the products that are on sale from our ice cream shop, we have scoops of ice cream in cones. And as Python developers, we like spotting patterns here. And as a test of Python ability, we can work out what's the rule here. That we've got a cone that costs €1 and some scoop of ice cream that costs €1. So if you have 2 scoops with 1 cone, it's €3. 3 scoops with 1 cone, it's €4. Ah, right, I can understand that. I'm ready to start doing my pricing model. So I start by creating a number of classes. I'm going to model the system. And I can think of ice cream and cones and scoops, and on a good agile development principle, only want to write code for the problem I know of at the moment, simplest possible thing that would work. I can then write the obvious rule code. But would that actually be a good idea? Well, I can then start to say, well, I want to have a flavour of the ice cream and I want a number of scoops. So I put in a scoop count, maybe it defaults to 1, and then I start to think, well, how am I going to produce a price? And I can have it take the price of a cone and the price of a scoop and put them together, and we're well on the way to a pricing engine. But then we look from this diagram about the tubs. And here we have, tub costs €1 and a scoop of ice cream costs €2. €1 making 2 altogether. 2 scoops in a tub is €3, but 3 scoops is €5. Now, my rule has broken, so I have to make the rule a little bit more complicated. Maybe I could put in an exception that the tub costs more than the cone in some circumstances. So I've now got an if statement in my cone, which I've now subclassed into different types of container. So I have a container class and a cone subclass and a tub subclass, right? We can cope with that. But then I realise that I go back to the business requirements and talk to people who hadn't actually explained to me that there are 3 different types of tub, different sizes. So the tub at the back can actually take 3 scoops of ice cream that are really large scoops, whereas, on a cone, you put the scoop of ice cream on top, and if it's too large, it falls off. So we start to develop more and more complicated rules, which isn't really how we want to do this, because there's one major problem with this, that when the rules change, and rules seem to change in two circumstances. One is when the business realises what the rules actually are that they didn't tell you about to start with, and the other is when the rules change because a competitor ice cream company just down the road has released a new package that has to be matched very quickly. The ice cream company doesn't want to have to wait for a 3-month development cycle for the developers to say, yes, well, I'll just go back into my model and I'll do a few more classes and put a few more exceptions in and we can handle that. And you end up with code that is very complicated and unmaintainable and requires development input and a long release cycle. What you want is something that's quick to respond to the market, particularly when you come to the last section, which is enormous cone for €7 with only 3 scoops in it, but they are very large scoops. I saw someone have one of these, and I don't know how they managed to eat it all. Or indeed, a bathtub of ice cream with only 3 scoops in it, but they must use a different size of scoop. And you can imagine all these rules would get far too complicated. So one of the important lessons we have learned in working on this project is the need to separate the data input from the pricing engine. That what you want is a pricing engine that can recognize patterns that you come across. We found a good tool in this process. Many of you will have come across Cucumber. There's a couple of equivalents in Python, freshen and lettuce. The principle we're using freshen there, we can say a scenario, you are given certain circumstances, and when you do something, you expect something to happen. These tests are behavior-driven development tests that enable us to express the problem in terms that non-programmers can understand. So our whole emphasis, the major point to go away from this talk is to think, how do I write something that non-programmers can use? So we've got an idea here that when the tests required to be written, you can get non-programmers to write these tests. And I have some examples here of the sort of tests that we wrote, and particularly the idea of product patterns, so that when you have something that is a discount, you don't want to be programming every separate discount. You want to say, well, how do we deal with discounts? How do we deal with included products? How do we deal with maximum number of things you can have? So we'll just look quickly at a number of these scenarios. So here's an included product test, and here we were using a pattern of a sandwich bar. Found it very useful having the model expressed in simple terms, so that when you came to some need to debug, we could go into the code of the pattern and work out what was happening in the very simple case, fix that, and then our code would recognize the real example. So here, given bacon sandwich includes tomato ketchup, when I ask to purchase a bacon sandwich, then tomato ketchup should automatically be added. So we think of a parallel example and program that up. Here's a conditional product that, given bacon sandwich with egg, includes coffee. You can imagine all the different scenarios that this could apply to. You've got a number of products that have to include something else free of charge, or it's a requirement for a customer to buy one of something. When I ask for a bacon sandwich with an egg, then coffee should automatically be added to my order. Some of the products are mandatory. So in our example of the pattern here, you can't have chicken, ham or egg filling without the bread. So it's a fairly obvious thing. You wouldn't really want to say, oh, I'll just save on the bread. Can you put the egg mayonnaise in my hand? It's reasonable to ask that the bread is a requirement. You might want to prevent having too many different products, so that you define a rule that says sandwich can have only one type of filling. So when I ask for sandwich with chicken and bacon, then I should be told I can have only one filling. And these tests can then be written. The point of cucumber or freshen is the tests are parsed by the Python code and turned automatically into behavior-driven tests that we can run as part of the build process. So it goes straight from a non-developer writing the tests to a build that either passes or fails, which is a very useful process, trying all the time to make ourselves redundant. The only reason for further development work should be the business comes up with a new pattern. So say they decide that there's a requirement to have 3 different types of cone, 3 different types of tub on a Thursday if it's raining. That will be a new pattern we'd have to program around. But the standard patterns, somebody wants to say, right, I've got a new included product to add to the range. I've got a new maximum number of somethings. All these rules should be able to be processed by the engine. One more here, the max occurs test that they've decided to allow only a single squirt of ketchup, and you're told that's the maximum. Right, I'm going to pass over to David Layton, who is our product and pricing expert on the project. He's a fellow contractor with me, American expatriate, Python developer, scientific computing, currently living and working in London, and he will explain the background, the other ways of doing things, and why we are programming the way we are. David.
So I typically work in non-software houses doing things for business people and trying to deliver the most value for their money, which typically means making something that can be maintained by a non-developer or someone far less skilled than the people that developed it in the first place. So what I'm going to talk about, and Rob's given us a great introduction, is how do you let the business express things the way that they think of things? As Rob said before, when the business wants to make a change, there's a lot of time constraints on it, typically because either competitors are trying to do the same thing or there's just something else on the docket. And we want to kind of streamline the usual process of going through and delivering modeling changes. So speed to market is key here. Basically, especially as Python developers, what we're really selling is speed to market. We can deliver things faster than developers in other languages typically can. So that's what we really want to be selling to our client, our ability to make deliverables fast. So if you look for the typical workflow, basically, product lifetime management is a multi-billion-dollar industry. There's lots of commercial solutions out there. And many non-commercial solutions. But typically, where you say, these are my rules, these are how I price things, these are things that are expressed in the code or through something that's different and separate from the actual modeling of the product. So when you want to make a change, the first thing that happens is that the sales and marketing people dream up some new promotion or they've come up with some new product. The difference being that when you have a new product line, typically you know it's coming. A promotion might be something that comes to somebody in their sleep, and they want to get it out fast. All right. So the next thing that happens is that the people who actually do the putting things in the model, typing it in, you need to allocate one of those resources, actually go in and make the configuration change. Now, there's a lot of work from various commercial products to make this something that an end business user can do, so you don't really need a technical person. So this might be in the same team. But where they seem to fall down on is the next thing, that since how it is that we deal with the model is not in the model itself and can't be interpreted from the model itself, you then need to pass this off to somebody who needs to actually make changes in the code. So this is typically going to be a developer. Now, this might have been extracted by the product that's been bought by just simply putting in new operators and determinants in order to evaluate things differently. And we'll talk about what those things typically look like. And then the next thing that has to happen is you've got to pass things off to the test team to have it verified. And a lot of us are very familiar with Agile. We're doing test-driven development, so this is something that we already have streamlined. We've got a huge bank of unit tests, behavior-driven tests, and what Rob showed you was the pattern tests. And that's actually some examples of actual pattern tests we use. So that's something that can happen really quickly. So let's talk about how we express the rules, how rules are typically expressed in various solutions. Now, basically what's happened is that every developer, their first thought is, okay, well, we need to interpret rules. This is something that's been done for several, since the 60s. We'll just invent our own domain-specific language that absolutely no one can read. It might be in reverse Polish notation. I've seen this in a lot of very popular products. And you can see here that what I've listed as some of the problems is that rules can be expressed in very ambiguous ways. Because you've expressed them in some operator, it's done by a developer, the naming conventions may be bad. But here, relating back to the ice cream, if I have a tub, if I have one of those giant tubs that Rob was showing us, then I need at least 2 scoops. The ordinality of the scoops needs to be 2. Now, you look at that and you think, okay, that should be just 2 for that particular tub, not for the order at large, but who knows? Unless I'm intimately familiar with the inner workings of this domain-specific language, as a business user, I'm not going to know. And as soon as I'm not confident that what I'm going to put in is going to act the way that I want it to, I'm going to simply defer the problem to a technical person. And what that means is that now I have to spend time actually allocating a resource to that. There can be a bureaucracy to that. There might not be available resources that mean that it can't be done in the timeline where the actual promotion has value, and the whole project gets scrapped for something as silly as this. The same rules can often be expressed in multiple ways, so here's another way to write it. This is a concept that you see a lot in these domain-specific languages, is to just simply say that one product requires another product or another grouping of products. So this just says here, if I buy a tub, it requires that this other fact be satisfied. So I'm going to show you a few more examples of bad things. Sometimes when you want one single behavior, so something that in the business they have a concept for this. There's a concept of, I have an includes relationship, I have a max dependency relationship, the sort of things that Rob was talking about. They have one single business concept for it, but multiple rules are needed in order to actually put this in. So you see here that the business comes to you and they say, okay, well, we want to say if you get 3 or more scoops of ice cream that you should get free sprinkles. And then you ask your product owner, you say, just sprinkles? I mean, certainly, anytime I buy ice cream, I'm allowed to make substitutions that are reasonable. Would it be okay if they had pineapple bits or hot fudge? And they say, yeah, sure. So these 3 rules go in. And God knows what the side effects of doing this is, but it satisfies the requirement at the time, and it's the next developer's problem to deal with the next set of requirements. And so they come to me the next day, and they say, okay, we're going to introduce a new product, and it's the Tuesday Sprinkle Special. They have to have sprinkles, otherwise it doesn't make any sense. It's a sprinkle special. So I put in my new rule. Maybe I'm a different developer. Maybe I don't know what I've done before in order to satisfy previous business requirements. And so I've said here that, this requires sprinkles. But up above I've said, pineapple bits, That's the same as if I had sprinkles. It's the same in any context. And depending on how this domain-specific language is interpreted, I might be able to get the Tuesday sprinkle special with something other than sprinkles, and then the business says that that's a no-no. So now I'm going to have to refactor all the rules in the entire rule engine just to get this one new thing in. And I personally, supporting enterprise software, have been in this situation more than one time. And it isn't fun, because the business asks you, well, why is this taking so long? It's only a simple change. Okay, so you might think, oh, you look at my examples, well, that's just a really crappy domain-specific language. You should just build a better one. And, I should build a better one, and people have been building better ones progressively for years and years and years, and they still are complete crap. And the basic reason for this is that, we're programmers, we think of things in a different way. The business people think of things in different ways. And it's just, it gives the business a degree of freedom that perhaps they shouldn't have. It gives, it's just like when you go from using a Mac to using Linux, there's possibly things that you could do that you shouldn't do. So you sort of need to gradually, get down to the level of I have more power because I've displayed more responsibility. All right, but this isn't going to happen. This is the level of you need to decide how much control you're going to give them. And from my experiences, I'd say you want them to be very, very confident in what they're going to be doing. So you want to make it quite limited. So what's the alternative? If we're not going to write a domain-specific language, if we want to keep things flexible, what do we do? Well, the first thing that we can do is we can represent our products as a graph. Now, typically, you always represent your products in a particular hierarchy because you're going to group them in some way. You're always going to say, well, these are the things that are in cones, these are the things that are in cups, and these are the things that are in something else. And you're constantly going to be refactoring like how it is that you use that. And you want to do that the way that the business looks at it, not the way that's easiest for you to program. If you have that big maxi cone that we saw before, that's also in a cone, but does it really need to be under cones? Because we know it's going to behave in a different way. It's something that the business sees in a different way. This is something extra that you're giving the customer. So you're really going to have two parents. So it's not going to be a straight hierarchy all the time. That's not the way that people see things. And if you try and take the way that the business is looking at it and shove it into some other format, you're just asking for trouble, because then they're going to start expressing requirements to you in ways that don't make any sense. So I say, let's represent our products as graphs, because that's what they are. A graph is something that has nodes. And it has edges, and those nodes are your products and your groupings of products, and maybe if you have some sort of abstract concept of charges or even rules, other things that you need, those things are all nodes. And everything else you should be able to express just simply by expressing some relationship between any two of those things, and that's an edge. And it has attributes. And everything else you can infer from that model. So here's a really, really bad way of displaying the ice cream products. I used Dia and threw this together pretty quickly. But the rules that I was talking about are actually displayed here, minus the attributes, because I don't have a nice way of really displaying those. But you've got your ice cream products. You might divide them up into your standard things and your specialties, and then you have your a la carte, which I've horribly misspelled there. And you've got your concept of scoops and your toppings, and everything's represented there, and everything's together. You've got your maxi cone being derived from two other things there. And as a business person, you can open up this sort of graph. In reality, it might be very, very large, but if you zoom into where the context is that you want, you get to see all the relationships. And you get to see things that are or are not feasible, or maybe things that you've modeled wrong incorrectly. So here I've actually done things that are a little different. So the black lines just show the hierarchy, so that in terms of how it is that you're grouping products and things like that. Nothing special there. I've used a blue line for saying these required rules that I put in before, which means if I get this, I have to have this here. And the green is the includes, which is, if I do buy this, I can get this for free. Now, some of the differences that I've made here is that instead of saying, oh, well, I had a rule before that said, well, if I order something in a tub, I have to get more than 2 scoops of ice cream. That's a requirement. I'm required to have more than 2 scoops. But as soon as I actually started making this graph, I realized, oh, wait, that also applies to the maxi-cone. In fact, all the specialties are big items. And so really, the relationship should be anything that's a specialty should have to have at least 2 scoops. So immediately, once I put it in this form, I'm able to visualize things that I got wrong before. And equally, we see that, you get a certain number of scoops. The numbers are the things here that you'd have to put on the attributes of that relationship. And that would be the sort of pattern that you'd be defining, the things that you'd be looking for, that you'd be saying to the business, this is something that we accept, this is how we interpret it. And then when I put in my Tuesday sprinkle special, I can just put in another includes and put it the toppings. And now here, you can see what I've done, and most of you have probably already realized this, is I've drawn the line from the Tuesday sprinkle special directly up to toppings. But we've said it's only sprinkles. So we can see here that it's clearly wrong. And it's immediately obvious to everyone, regardless of their level of technical ability. So as I said before, it's a big business doing this sort of product modeling. So what we're not doing as a part of our project and what we're not talking about here is actually how you do this product lifecycle management. And obviously, just having a diagram of a graph isn't something that you want to give to the business users for multiple reasons. You want something that's graphical that they can manipulate, that they can use to define these things. There's a number of things available. SAP has a product lifetime management. We use a smaller vendor that we can't really mention. But these things exist. You could easily write a graphical library, put a UI on top of it, and allow people to put it in there. But you wouldn't have the sort of really polished user interface immediately that the business really likes. And again, if you have something that's difficult to use or the business isn't confident that it behaves in the way that they want it to, they're simply going to defer it to a technical person, and then you've kind of lost the whole point of doing the project in this way. So what we've managed to do is move the complexity from the actual interpretation, so from the modeling and the pricing engine, and move it to the way things that are expressed. And by being able to move that complexity there, we can abstract the complexity. They don't need to know how it is that we've implemented this particular inclusive rule, how that behaves. They don't need to know. They just need to say this product relates to this product as an inclusion. This is an inclusive product. That's all they have to say. And that gives you a lot of flexibility between the model and the interpretation of the model. In fact, the way that we've written this, because everything's so model-driven, we could actually code up in XML. So basically, there's a publishing mechanism from the modeling product we do use, which gives things out as XML that we then map back to a graph internally. We could just as easily go to a database, just anything that will give us the information about the model. But we could actually get that XML, program it up with the ice cream example that we've shown you, and we are very confident that it will just work. As you saw from the test that we had before with the bacon sandwich and the tomato, that's actual code that we run. So that's one way that we test that everything really is model-driven, is to put it in a completely different context and see that everything still works as we expect. It also allows us, since we've defined those pattern tests, we can point the business to say, well, these are the actual patterns that we support. These are the things that you can go and put in the model, and we can guarantee that it's just going to work the way that all the others worked. And it's only when something's very logically different that we have to put in a new pattern. Oh, it also gives us the ability, if we find a pattern that's actually the composite of other patterns, so you have some business concept where it really means, oh, you require this product and you exclude some other products, or something that you could imagine just being a composite of things that we already have. We can allow them in the model to express it in a new way, and then behind the scenes just deal with it the same way that we always have. And then the business is happy. They don't have more rope than they can handle. and we're happy in the background because we have to do very, very little to get that to market. Now, one thing I want to speak very briefly about is how you should interpret rules. And basically, the seminal work on this is listed up here by Charles Fourier, and it's the REAT algorithm. So this is going way back to the 80s when people were doing expert systems and having computers that would figure things out by just a rules-based system. And the only thing that I really want you to get from this is that if you go into, say, a grocery store and you start looking at people's shopping carts. Now, in the store, they have hundreds upon hundreds of various products, and yet you'll see a lot of similarities between the shopping baskets that you see. People typically go and buy milk, bread, eggs, butter, these things. Sorry, that means 15 minutes left? Yeah, including questions? I'm not going to keep you guys from lunch. I'm going to really try to zoom through the rest of this. Anyway, so what you're going to realize is that the differences between what people buy and your entire product catalog is very, very, very small. Because most people don't go in and buy 12 of everything in the store. They go in and buy a select group of products, and the people after them buy many of those same products because some things are wildly more popular than others. And Charles Fourier realized this, that when you're designing a rule system, and the way that I believe that he put it was that even though the rules don't change, the majority of the facts don't change either. The facts of what it is that they've bought change in a much smaller proportion. So the idea is basically that you then create a graph of the actual conditions for a particular rule applying. And what happens is that you have conditions that are composed of other conditions, and those composite conditions may be used for some rules, whereas you have to compose it with another composite condition in order to get it to go. So here, what we've modeled as a graph here is that if I do X and Y together, it might trigger some set of rules that I haven't actually put in this graph. But if I also put Z, then this particular rule that's down here at the bottom, foo, is going to be triggered. All right? Now, you're asking yourself, this doesn't make sense. What do you mean by all this? Why would you do this, even if you know that the facts aren't wildly changing or aren't wildly different from request to request? Why are you doing these things? Because it's always our gut instinct. If you go in and program a rules engine very naively, what you do is you say, okay, here's the things that they've bought. Here's the first product. Oh, well, what type of product is this? Is it this type of product? Oh, if so, go over here and do this function. If it's this type of product, go over here and do these things. And if it's that type of product, do that things. What you're basically doing is you're evaluating the conditions for every single rule in your entire engine. So in all your product configuration, all your pricing, you're evaluating every single rule, even though usually you're only concerned with a small subset of those rules. So what you're doing here is you're basically turning it on its head, and you're allowing the conditions to actually find the rules instead of the other way around. And so if you don't do it this way, you're going to find at the end of your project that you have some very serious performance problems. Don't look up the REAT algorithm on Wikipedia. Don't read about it through one of the other sites that you're going to Google. Really go to this paper and see what it's all about, because everything else is just a really poor reinterpretation of the paper. Okay, so what you really need to know, like I said, the facts, what people are buying, must find the rules, the things that you care about. Now, I've often thought that maybe the best way of doing this is just do the observer pattern. You can go in and register the conditions under which they have to be met and put a callback in. It all sounds a bit complicated. You do get something from this, and you don't have to worry about what order should my rules apply in. Like if they're of this particular type, does it affect it if they, is it different if I apply it in this order rather than this order, and how do they interact? You get around a lot of that. But with the way that we've done it, since we've made our rules part of the product graph, we already have a very easy way of figuring out which rules are actually relevant to the things that people have bought for a particular order. And the way that we, a particular sales order. And the way that we've done that is simply, we've got we attach the rules that care about a particular product to those products. So then we can very easily just say from the adjacency matrix in our graph, what rules are actually connected to this product and are they valid, and only do those. So for now, for our performance concerns, given that we're working for an ice cream company and there's only so many different types of ice cream, it works quite well. Now, the other thing that I want you to know is that there's lots, since this has been going on since the 80s for expert systems, there's a lot of mature libraries for actually handling your rules, and they are written in domain-specific languages. And you'll see some parallels between the things that I've written. And you do have to be concerned with things like what order have you defined your particular rules in and things like that. But these don't necessarily conflict with what we've been talking about doing things model-driven, because once you get the model in, it's up to you what you do with it. You can actually translate things to a domain-specific language. But we haven't seen a need for this, so we haven't done that. Also, it should be noted that there are wrappers for PyClips, for clips called PyClips that you can use to do these things in Python with. So, Rob, do you want to give the summary? All right, I'll keep going then. All right, we've got 10 minutes. Everyone's going to eat today. So, as programmers, we really, really like writing things in terms of operators and reverse Polish notation. We absolutely love creating our own domain-specific languages. There have been talks at this conference of exactly how they do it and wonderful tools that allow you to do this. You can pick a myriad of ways of re-implementing Common Lisp. And that's our job. And you can even write a templating engine while you're at it. But we don't like to write exceptions to rules because they're rules, they're logical, they're right, they're pure. So we don't like writing exceptions to them, but the thing is that the business doesn't care. The business doesn't care about your structure. They don't care about the rules that you already have. They don't care about these things. What they do care about is how long is it going to be before they can have the next, the idea that just came to them put in there. So if you don't do things this way, pricing can become unmaintainable without the developer. And that's a really good way to have job security, as being the only person that can actually go through and refactor all of the rules in the entire engine to put in the new behavior. But Rob and I are consultants, and we like to get the work done and get out fast. So what we've talked about really is separating the data, separating the things that we want to express from the code, and Python makes that absolutely beautiful. We've got all sorts of meta classing that we can do in order to achieve this. And since Python has duck typing, it's absolutely amazing. If I find this, if I'm going through the XML and I see these fields and this particular structure, that's my pattern. That's it. And anything else, it's absolutely forgiving about it. It'll just go through and do the best that it can to interpret things. And if the tests don't pass, then the tests don't pass. And we've got to go back to the drawing board a bit. But we find that doesn't happen a whole lot. Also, we've talked about how, your model can make complicated rules out of even with simple patterns, even with simple ideas, things that the business can express in a very, very simple way. You can get complicated rules. And there's a variety of ways of really dealing with that. So I'm David Layton, and that's Rob Collins, and this has been our talk. You have our contact information here. You can find me on LinkedIn. Are there any questions?
I'm wondering about the end products of this. What do you get out at the other end in the way of? Do you put it in the cash? Do you put it in the cash registers or into big catalogs, or where does the information end up?
Okay, so what we're doing on our specific project is we're doing JSON over HTTP. So they'll bring in, they'll give us a JSON request, And it'll say things like, I want to buy these products together because what you buy with other things matters. And then what we typically give back, if we're just evaluating it, what we give them back is, okay, well, these are the things that you've told me to buy. Now, either you can't buy them that way, and I send an error message that tells you explicitly this is why you can't buy things this way. Or we give them back a list of not only the products that they've asked for, but the products that they have to buy. If there's a very specific, you have to buy this with this, the things they have to buy, along with another object that we didn't talk about, which was called charges, which are another node in there. You may not charge somebody for this product costs this product costs this, but you bought this group of products and we evaluate them this way. So they get a list back of charges, and that's what's going to appear on their bill. And that gets passed off to our service is stateless, so it goes to basically the controller of state for different orders and things like that manages the different systems. Now, right now, we currently don't cache things. But it's quite foreseeable that that's exactly what we'll do. We'll hand it off to this service, and the service will either cache them or we'll hold a cache on our side. Just simply because, like I said before, you go to the grocery store, you see a lot of people have the same shopping cart or similar shopping carts. And as we know, Python isn't known for its performance, so it's a great way to really make things fast is to just cache it that way. Has that answered your question?
Yes.
Don't be shy. Okay, well, thanks, everybody. Any parting words, Rob?
Just one other thing. If anybody is in London and particularly likes ice cream, our client is recruiting at the moment. Come and see us afterwards.